In class today, we did a demonstration where we had two test tubes. And in one test tube, we had 25 milliliters of water. And in a second test tube, we had 14.5 mils of water. And we had an aluminum rod that took up 10.5 mils. So both test tubes had 25 mils of total material. What we did is we took a Cheeto and we split it in half to exactly half. And then we ignited the Cheeto underneath each of those test tubes. And we observed the temperature changes to be as follows. The first experiment, where it was just water, the temperature went from 20 degrees to 28 degrees. In the second experiment, where the aluminum cylinder was present, you experienced a greater temperature change. The water went from being 20 degrees to 42 degrees. So the goal of today's demo is to get you guys to figure out why this difference was there and answer a couple guiding questions in the process. The first question I wanted you guys to answer was, what's a calorie? And then figure out what that means, and then figure out what a joule is, look up what calorimetry is, determine what specific heat is, and then think about how we can determine the quantity of heat transferred from one object to another. And then once you were done with that, I wanted you to figure out the efficiency of my experiment and any improvements that could be made, and clearly there were a few. So let's take a look at first measuring energy. So a calorie, small c, is the amount of energy required to raise the temperature of 1 gram of water by 1 degree Celsius. That's a little bit different than the kilocalorie or big C calorie that we see on food labels. So a big C calorie is really 1,000 of small c calories. And a small c calorie can also be described as 4.184 joules. And that's the unit of energy we use in chemistry. Now, when we're measuring calorimetry, what we're doing is we're measuring the energy transfer. And this is dependent on something called the specific heat. So not all substances require the same amount of energy for their temperature to change. Specific heat is different for aluminum than it is for water, and that's why we observed a difference in the amount of temperature change from experiment 1 to experiment 2. Specific heat is the energy required to raise the temperature of 1 gram of a substance by 1 degree Celsius. And again, all materials have different specific heats. So if I was asking you what the specific heat of water was, what would it be? And what would the units be for the specific heat? So you can see that a calorie is the amount of energy required to raise the temperature of a gram of water by 1 degree Celsius. And a calorie is 4.184 joules. So we could then say the specific heat of water is 4.184 joules per gram degrees Celsius. And we're going to use that when we calculate the energy transferred to the water. Here's just a table that shows that water has a much higher specific heat than aluminum. We could do calculations with this, but I'm not expecting that for today's demo. But in calculating the energy transferred to the water, what we can do is use the equation Q equals mc delta T, where Q represents the heat transferred, and that's measured in joules. M represents the mass in grams, and specific heat is measured in joules per gram degree Celsius. And delta T just means the change in temperature, so what it finished at minus what it started at, and we describe that in degrees Celsius. So in this experiment, the temperature changed by 8 degrees, and since we had 25 mils of water, and we know the density of water is 1 gram per mil, that's 25 grams of water. So we could calculate the heat transferred by multiplying that specific heat, 4.184 joules per gram degree Celsius, by the mass, which is 25 grams, by the change in temperature, which was 8 degrees Celsius. And we can see that 840 joules of energy was absorbed by the water. So if we're calculating the percent efficiency, what we first have to figure out is how much energy should have been transferred based on what the side of the bag says. So if we have half a Cheeto and there's 160 calories, big C calories, in 13 Cheetos, and there's 1,000 little c calories in a big C calorie, and there's 4.184 joules per calorie, we see that we should have ideally been able to transfer 26,000 joules of energy from the Cheeto to the water. And clearly we didn't get that. We only had 840 joules transferred out of the 26,000 joules we predicted. So that's a 3.2% efficiency. And that's really just pretty sad. So I'm sure there's a lot of things I could have done better. Why don't you guys tell me what they are?